In today's video, I will show you how to move an air conditioner from one place to another. I'll explain how to properly pump down the air conditioner and restore the gas. I will share 3 methods with you that will allow you to restore the gas. So let's start the video and I will give you the full demonstration. First, let's talk about the tools you'll need to perform this task. If you're a professional, you probably already know which tools are required, but this part is for those who are new and don't know about it. I'll quickly tell you the tools you need. You'll need an adjustable spanner, then a screwdriver, and you will also need Allen keys. Specifically, you will need a 4mm Allen key and a 5mm Allen key. Now I'll explain the first method. However, for all 3 methods, you need to have a helper with you, someone who can immediately turn off the electrical supply to the unit. This is important because if the unit runs for too long, there's a higher chance it could get damaged. Right now, I have the unit in my workshop, but if your unit is installed somewhere far, then you should have your helper stationed at the main switchboard so they can quickly turn off the unit whenever needed. Make sure you stay in constant communication with them. First of all, there's a box attached to the unit. We'll open it by removing the cover. Once the cover is off, you will see 3 dead nuts. Use your spanner to loosen these nuts. Turn them anti-clockwise and they will come off. That's how we remove all 3 dead nuts. As you can see, the gauge is installed and the pressure is showing around 200 psi. Next, you need to check what size Allen key fits. I already know that we need a 5mm Allen key for this unit. I'll slightly loosen both valves using the L key. Once both are loosened, we'll turn the unit on. After that, I'll explain the next steps. Now the unit has started and you can see the gauge beginning to drop. As soon as the compressor starts, the gauge needle will move downward. We'll wait for the compressor to reach its full speed. Next, notice that this pipe here is the discharge pipe and this one is the suction pipe. We always close off the discharge pipe first. I'll gradually close it while keeping an eye on the gauge. As soon as the gauge needle reaches 0, we immediately close the other valve because at that point, the gas is sufficiently stored according to the gauge reading. Now that I've closed both valves, we must turn off the unit immediately. After that, you can disconnect all wiring, and this is how you dismantle the unit. Now, the second method of storing gas is essentially the same as the first one, with the same requirements. However, I'm explaining this method for those who do not have a manifold or gauge. You can still pump down the unit easily, but you have to work very quickly to avoid damaging the compressor. Here's what you need to do. Start the unit. After a moment, the compressor will turn on. As soon as the compressor starts, close the discharge pipe first, just like I explained in the first method. Then, after about 25 to 30 seconds, close the suction pipe. Don't wait any longer than that. Now you can see my unit has started and it's drawing amperes. I'll wait briefly for the compressor to reach full speed, and then I'll show you exactly what to do next. Now you can see the compressor is drawing about 4 amps. We'll close the valve, and as soon as we do that, you'll notice the amperage starts to drop. After about 30 seconds, we'll close the other pipe as well. You can see the amps continue to go down, which means the gas is being stored. Then you should turn the unit off. This is a very simple way to store your gas without using a manifold gauge. Generally, we divide units into 2 categories: DC inverter units and non-DC inverter units. In principle, you can store gas in both types, but there are some conditions you need to understand. 1. Capillary tube systems. If your DC inverter or non-DC inverter unit uses a capillary tube, you cannot automatically pump it down. This is because there's no direct control over the capillary tube. It just allows gas to flow in and out without any regulation mechanism. In this situation, you must store or pump down the gas manually, as I demonstrated in the previous methods. 2. Electronic expansion valve systems. For DC inverter or non-DC inverter units that have a PCB and an electronic expansion valve, there is a possibility of automatic pump down, but only if the brand or manufacturer has enabled this function in the system's programming. If they haven't, then you still can't automatically pump down the unit. The reason an electronic expansion valve can allow for automatic pump down is because it's controlled by a microcontroller. The microcontroller can open or close the valve precisely, controlling the flow of gas effectively. 3. Half-automatic pump down. In many units on the market, there's only an electronic expansion valve on one side, usually on the liquid discharge side, but no valve on the return, suction side. In that case, you can't fully automate the entire process. One side may close automatically, but you still have to manually close the other side. Here's what happens in such a scenario. The electronic expansion valve closes automatically when the compressor starts, causing the gas to be stored in the outdoor unit, condenser side. Meanwhile, you have to manually close the suction side to complete the gas storage. Please note that only a few brands actually implement a fully automated pump down function. Most companies don't include a dedicated valve or the necessary control in their standard units, so the manual method remains the most reliable and commonly used approach. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.